So now that we have these three different transformations and their horizontal and vertical variations in our toolbox, what I want to do is I want to look at some examples where we have functions that have multiple transformations and how we can kind of sort all of these out and see what the net effect is on the function's graph. So I've got an example here for us to start with. And when you're looking at these, the first step is kind of break this down and say, okay, what's the base function? If we strip away all the transformations, the reflection, the horizontal shift, the vertical shift, what's left? Right, well, the function that's left here is y equals the absolute value of x. And I'm going to switch back to using y's, right, because we're graphing and I really want to think about x and y coordinates. All right, so that's where we're going to start. Then here's what I'm going to do to get to my final graph, the graph of this big absolute value function. I'm going to start applying transformations. And say, okay, well, then I'm going to graph y equals the absolute value of x plus 1. Then I'm going to do negative x plus 1. And then I'm going to do this downward shift. Okay, and you see where I ended up after putting all these transformations back on. That is the function that I was asked to graph. All right, so let's see how this works. I'm going to start with y equals the absolute value of x, and that has this kind of V shape. All right, now, what effect does this plus 1 have? Well, this shifts 1 unit. Remember, this is the backwards 1 to the left. Positive 1 shifts to the left. So what's that look like? Well, when I do these, I like to kind of focus on a specific point, like that vertex, right? And I'm going to see where does that vertex end up. Then I can kind of sketch the rest of the graph around it. So that vertex moves from 0, 0 to negative 1, 0. And the rest of the graph still has this same V shape. All right, so let's go to the next one. What effect does that minus have? Well, this reflects across the x axis. All right, so that did not move that vertex. That vertex point is still right where it is, right? Because negative 1 times 0 is still 0. The rest of the graph gets turned down. Right, and then finally, what effect does that minus 2 have? This shifts 2 units down. All right, so again, focus on that vertex. It went from here down 2 units to here, and the rest of the graph stays in that inverted V shape, and that's it. That's the graph of my function. Right, done using transformations. So there's two really big issues that come up with students. First, how do I find the base function? You kind of saw how I did that already. I just kind of rubbed out or scratched out all of the transformations and looked at what was left. Right, and the second question is, in what order do you apply the transformations? And ultimately, the answer is you can do them in any order. Right? But it can get some orders are trickier than others, especially when you have both reflections and translation. So the rule I like to use is I start at the variable and I work my way out. The closest to the x was the 1. Then I went outside the absolute value with kind of a grouping symbol and did the minus, and then I took a step further out and did the minus 1. And that gave me my function, my graph, right? That's how I like to do it. If you do them in another order, you can get the right answer. But like I said, it can get a little tricky. This way, I think, is the path of least resistance, the one where you're less likely to make some strange technical mistake. All right, so I've got another example here. And this one has a little bit of a subtle issue, right? you could reasonably look at this and say, well, this is a translation 1 unit to the left, because that's what a plus does, right? It goes backwards. But you'd have a problem, right? And the problem here is that the rule is you're translated by the amount that's being added or subtracted from the x. And that 1 is not being added to the x, it's being added to the minus x. All right, so, but we can fix this, right? All I'm going to do is factor a -1 out of the parentheses. And now you can see what's going on. I am actually subtracting 1 from the x, which will be a shift to the right. All right, so now let's take a step back here and think about what our base function is. So if I get rid of the dilation, the reflection, the translations, all that's left is y equals x cubed. All right, so that's going to be my base function. Y equals x cubed looks something like this. Let me make that a little better. It's got to go through -1 here, right? So it's going to go a little more like that. All right, now, in what order do we apply these transformations? I'm going to apply them in the order based on what I'm seeing in the original function. All right, so I'm going to do, and I'm going to have to do this on the same graph here, because I don't know, if I added one more, it would have gotten too small. So I'm going to do y equals negative x cubed. Then I'll do the translation, then the dilation, and finally the vertical shift. Okay. All right, so let's put these on here. What effect does that minus x have? That flips, it reflects the graph across the y axis. So the new graph is going to look like this. Then I'm going to take that graph and I'm going to shift it 1 unit to the right. And I'm going to kind of focus on this point here at the origin. If I move that 1 unit to the right, it ends up here. And now my graph looks like this and like this. Then I'm going to do the dilation. That stretches the graph. It's going to make it go up and down faster. It's going to stay here at this point because 2 times 0 is still 0. And then it's going to go up fast and down fast. And then finally, this -3, that is a shift 3 units down. So I'm going to focus on that same point again, push it down 3 units. And then we've got still this rapidly changing graph. And there you go. That's it. That's our final result. So you see the result here of, what do we have? A grand total of 4 transformations, right? And the order, right, and like I said, the order is always going to be something you have to stop and think about. In this case, I kind of refer back to the original function, which is a good plan. Another kind of rule of thumb to keep in mind is do reflections before transformations, right? Reflections and then transformations. If you don't, what happens is the line you have to reflect over gets translated along with the rest of the graph. So if I had done this -1 first, I would have had to reflect across the line x equals 1 instead of the y-axis, which is x equals 0. And that to me is, it's not hard for me, but when you're just starting out, I think it's easier if you just try to get those transformations in first. Get the reflections in first, and then focus on the translations. All right, so what's next? We're coming to an end here. of our discussion of functions, and in the last couple of lectures, what we're going to do is we're going to focus on ways we can actually use these functions to model real-world situations.